Good evening, everyone. I'd like to welcome everyone to ASLM Conference 2021. This session is titled Increasing Access and Efficiency of Diagnostic Networks using OptiDx, an open access network analytics tool. OptiDx is an open access tool for supporting diagnostic network optimization activities, particularly in low and middle income countries. It's designed to empower countries to use DNO sustainably, both to optimize current testing capacity and to plan for the future, such as to inform the introduction of new diagnostics or expedite new testing strategies. It has been piloted in a few countries this year and will be made available for wider use in more countries going forward. This session objective will highlight the value of DNOs, as well as OptiDx to inform diagnostic system strengthening interventions across multiple diseases. It'll also provide an overview of the OptiDx software and share some lessons learned from its application in countries. My name is Jason Williams. I am the Technical Branch Chief of the Supply Chain Division within USAID Washington. We will have 4 speakers today, including myself with one of the opening presentations. Heidi will have the second session within this session titled Introduction to Diagnostic Network Optimization and OptiDx. She is the head of FIND South Africa, leading the project. We have Shawn Pandey, which will do a demonstration of the OptiDx tool software. He's a supply chain analyst within FIND. And then we have Paolo Chunga, will also provide some country experiences using the tool. He is a laboratory advisor within the Ministry of Health within Zambia. I will, during the session, at the end, will facilitate the Q&A, and then we'll also have Sergio Carmona, who is the Chief Medical Officer within FIND, facilitate the closing remarks. So with that, what I would like to do is hand it over to the conference organizers and begin playing the pre-recorded presentations, starting with myself, which would include data-driven planning of laboratory systems. Thank you and welcome all.
So good morning, everyone. My name is Jason Williams. I am the Technical Branch Chief within the Supply Chain Division of the Office of HIV/AIDS. I'm supporting PEPFAR in relation to laboratory procurements as well as laboratory network strategy development. Today, I'll speak very briefly about some of the data aspects to employ it as post-DNO. I'm not going to talk to specifics of conducting a DNO. I'm going to talk about some of the operational planning aspects and data elements that are required as part of ongoing monitoring and adjustments to DNOs over time. Colleagues will speak more specifically to some of the DNO aspects and some of the data elements that are required to do a DNO. I'm going to talk post-DNO and operational planning. So we do a DNO obviously to address somewhat of a more comprehensive network approach. What this does is it helps us to define a clear strategy, to define a laboratory network need and the supportive structures that are necessary to achieve effective program growth in an effective manner. So the DNO basically defines the baseline of the current laboratory network, and then uses sophisticated algorithms to basically develop different modeling strategies that can be employed to address particular efficiencies. We leverage the DNO from a procurement perspective to identify opportunities to reduce pricing as part of an all-inclusive per test cost. This is a strategy that PEPFAR has employed more recently and has had great success in implementing in some of the larger countries. But basically, we take the DNO and we leverage that to understand, the space for new instruments and helping us negotiate new contract models that include service and maintenance, and more importantly, the data solutions that are required to monitor instrument and end user performance metrics. I also use it from a commodity management component. It helps us to define procurement strategies for product, understanding where demand is, usually from an annual to a multi-year kind of procurement strategy to ensure reagent availability over time. So following a DNO, well, actually, as part of most DNOs, there should be an operational planning aspect to it. And what this does, it defines roles and responsibilities within a traditional kind of cascade of events to achieve the final outcome of the DNO. This is not an exhaustive list, but it's illustrative of some of the core components. And when we're talking about the data elements that are required to kind of monitor the implementation and the efficacy of the DNO models that are being employed or implemented, I see two kind of core components here. One being on the sample transport side, and one is actually on the instrument side. So as part of sample transport planning, obviously national systems need to be developed, policies need to be developed. There could be adjustments in routes, but ultimately the sample transport approach should include some standard KPIs. And these data elements are of particular importance because it tells us how well the network is functioning. Ideally, you should be capturing data monthly on the sample transport, but then having quarterly stakeholder reviews to inform adjustments potentially to the DNO itself, or even to identify other operational issues as part of implementing the sample transport approach that's been delineated within the DNO itself. On the instrument side, when we're procuring under all-inclusive contracts, we do include core KPIs embedded within those contracts, and those are critical for us to monitor. Also, and it's a big aspect of not only monitoring the machines itself, but monitoring the staff that are using, understanding testing volumes, as well as understanding whether or not the manufacturers are actually adhering to the contract terms within the scope of the service level agreements that we sign as part of the all-inclusive agreements. So when considering some of these activities that are defined within the operational plan, again, the two largest elements I would focus on as part of a data visibility kind of approach would be on the sample transport and the instrument kind of performance metrics as part of that operational plan. We talk about some of the data requirements for doing a DNO. Obviously, it needs to be very high confidence in the data itself. Poor quality data doesn't allow us to have a high level of confidence or even a level of precision as it relates to some of the strategies that come out of that. So high quality data is a critical component to kind of focus on when doing your DNO. And I think, as I've alluded to on the other slide, we have the sample transport and we have the instruments themselves, and having KPIs that are nationally standardized and measured and reviewed monthly and quarterly reviews can help address issues that may not surface as part of the initial implementation of the DNO, and it allows us to have the flexibility to adjust some things once the DNOs are moving forward. We use it again for informing referral efficiency gains, but more importantly, it's about enhancing the negotiation strategies and informing the procurement approach. And I think at the end of the day, ultimately, as part of a DNO, the only way for it to truly be successful is obviously to provide a transparent approach with a defined operational planning structure. And what that does is it allows to ensure political will and improve coordination with various stakeholders that are working within that space. And ultimately, it should help with effective implementation, and ultimately, at the end of the day, will help achieve greater efficiencies as part of implementing the DNO. So with that, I realize it was very, very brief, but again, the takeaways are on the sample transport and the instrument data connectivity solutions and data visibility around instrument performance. So with that, what I'd like to do is hand it back over to the facilitator, and when time permits, I'm happy to answer questions as necessary. So thank you very much.
With further ado, I would like to introduce you to Heidi Alberts, a dear colleague of mine. She's the head of FIND in South Africa and has more than 20 years or so of experience in TB diagnostics. Her background is in pharmacology, and many of you may know her. she's been instrumental in driving diagnostic network optimization with the partners, as Jason mentioned. So over to you, Heidi.
Hello, I'm Heidi Albert from FIND, South Africa. I'm going to be giving an introduction to DNO and OptiDx. Testing remains the weakest link in the care cascade, and we know that basic diagnostic capacity is available in just 1% of primary care clinics in low and middle income countries. And inefficiencies in diagnostic networks limit testing, impacting patient care. Tests are often unaffordable, and even when available, testing devices may be underutilized. And delayed or inconsistent test results can't be used to inform clinical decisions. For TB and HIV and across other diseases, we know that gaps in diagnosis and linkage to treatment are still widespread. So how do we design the most optimal network that can deliver these services where they're needed? Well, it's complex because there are many different factors to consider. Firstly, multiple devices and tests are needed. There are a large number of different sites to consider, from labs to health facilities to hubs. And yet coming up with the optimal design requires a multitude of different data inputs and assumptions. And it very much depends on the context. So this includes variations in disease epidemiology, health systems, availability of tests, and importantly, the geography. And there are obviously budgetary considerations and constraints to take into account. So what does an unoptimized network look like? Well, firstly, one of the features is that there's a lack of clear visibility often into where are the gaps, and also what are the opportunities for improving the system. Secondly, we see inefficient use of device capacity, where some devices are overburdened and others are underutilized. There are missed opportunities to improve access using available capacity, and avoidable costs, both in procurement and ongoing operational costs. And lastly, we see often fragmented and inefficient sample referral systems, often with a single disease focus. So what is DNO and what can it help us to do? So DNO is a form of geospatial network analysis. It helps us to use local data to analyze the current diagnostic network or system, and then to recommend the optimal type, number, and location of diagnostic services and an associated sample referral network, and really to tailor this to the local context and constraints. And in doing this kind of analysis, it can help inform how we can best expand access to services to meet disease targets and achieve health equity, at the same time maximizing the overall efficiency of the system to allow us to make the greatest impact with constrained resources. So at a high level, we can think of DNO in 5 steps. Step 1, we define the scope. So including the different devices and tests that we want to include in the analysis, and then identify specific objectives based on the country context and priorities. So this could be improving turnaround time of services, it could be reducing costs, it could be improving efficiency, or commonly a mixture of those different priorities. Secondly, we collate and prepare the data. I'm just showing here some of the key data sources we need for a DNO exercise. We need data on sites, on testing demand, on costs, the different test types within the network, and then the rules or policies that govern transportation and sample referral. For step 3, once we've collated the data, we use different software to build the baseline model. And this allows us to understand the current system and also refine the objectives for the DNO. And then step 4, once we've built the baseline, we can then look at adjusting different inputs and constraints to help us think through potential future scenarios. Some of these changes could be looking at different changes in testing demand, could be adding sites or devices to the network, and making changes in the sourcing and transportation policies. And frequently we want to also apply constraints, most notably around turnaround time or service distance, to make sure that the network can deliver results within the required time. And after running a number of different scenarios, we can then analyze and compare them and really balance the access, the cost, and the efficiency that can be achieved with different scenarios and decide on the right balance for the local context. So having done that, then select the preferred design for implementation. And based on the different, what the different changes might be, there's a number of different actions that would then need to result. So it could be relocating devices, it could be adding new tests onto existing devices where there's spare capacity, establishing a sample referral system, and maybe even opening new labs or procuring devices. And then it's important to monitor progress and evaluate the impact of implementing these recommendations to see that the anticipated improvements in the network have in fact been achieved. And where changes occur in key inputs, particularly testing demand, for example, it's then important to rerun the DNO analysis and check for any changes that might be recommended. So to conclude, DNO, it's a highly adaptable approach. It's disease agnostic, can be used to look at multiple different tests across diseases. And it can help us think through how best to optimize our networks. It can allow us to think about improving patient access, but at the same time balancing cost efficiency. And at its best, it should be run within a multi-stakeholder framework where the country leadership, the Ministry of Health, is taking the lead role, but also engaging key partners in the process. And it should be embedded within a larger set of system strengthening initiatives and other analyses that countries may be doing. And it's really complementary to things such as needs assessments and other capacity building initiatives. And really it can help inform decisions based on the local context and the priorities. So I'd just like to finish off by giving a brief introduction to the OptiDx tool. And you'll see much more of this in Mayank's presentation a little later in the session. So OptiDx is a web-based open access tool for conducting DNO analysis and also a more detailed route optimization. The tool was developed by Find, Lamasoft, a Cooper company, and the USA Global Health Supply Chain Program Procurement and Supply Management Project. And the development of OptiDx has been supported by the Bill and Melinda Gates Foundation through a grant to Find, and hosting and maintenance of the tool will be supported by the US President's Emergency Plan for AIDS Relief, or PEPFAR, by the USAID GHSC PSM project. And the tool will be freely available to users in low and middle income countries to support their efforts to better understand and optimize their diagnostic systems. Thank you very much for your attention.
Next speaker, we'll be hearing from Shawn Pandey, a colleague of mine at Find. He's a supply chain analyst. And Mayank's going to be presenting a demonstration of the OptiDx software. Over to you, Mayank.
Now about OptiDx. So OptiDx is a web-based application. It is an open access tool. The tool is disease agnostic and has been designed for diagnostic networks and LMICs. The key functionality of OptiDx is that it builds an adaptable digital model of the diagnostic network. It is user-friendly with high visual capabilities and a host of optimization options. It can empower countries with industry best practices in supply chain analytics, and it requires minimal prior expertise and network optimization. Over here on the slide, we can see the landing page of the tool, and we will be going into the tool in the next section of the demo. Next slide, please. Here we can talk about the process of the tool at a high level. So the first stage, as my colleagues have already mentioned, is to define the scope of the analysis and collate the required data. Then the next stage is to build the baseline model, which we can do in OptiDx. There are 11 steps for building the baseline model, after which the digital representation of the diagnostic network will be available on the tool. The third step, which we recommend, is to review the baseline and to identify the gaps and refine the DNO scope. After doing that, the fourth stage would be to run optimization scenarios, as we've highlighted here, using change the network approach. The fifth step would be to compare the outputs across scenarios and select recommendations for implementation. So we're showing that through some high-level charts over here. Now, this process overall is iterative, and generally the countries go through this process in multiple stages and select the best scenarios out of the available scenarios. Next slide, please. Here we can see the high-level data inputs required for building an optimization model in OptiDx. So we require costing information, which can be captured in data template called the OptiDx Diagnostic Costing Tool. Then we also require structural and transactional information for the model, which includes locations, test-in devices, testing demand, sample referral information, and transportation policies. All of this information is collated and it goes into the OptiDx tool through an automated process. Next slide, please. Once the baseline is built for a country, we can review the network through charts and graphs. On the left, we can see the different KPIs we can measure for a country. For example, in terms of costs, we can measure the total cost, test variable cost, device cost, and transportation cost. We can understand the demand by different test types in case we are modeling a multi-disease network. We can also understand service distance and average device utilization metrics. Next slide, please. And this analysis can be done at a granular level, which can be admin 1, admin 2, or even below that at a facility level. Next slide, please. And once we're comfortable with the baseline analysis, we can run scenarios using the different options which you can see on the screen. We can change the demand, we can change transportation policies, we can change testing policies, and we can also add or remove locations from the network. So this was a high-level overview of the tool, and now we will go into a brief demonstration of the web application. So I'd request the team to play the demonstration. We will be looking at Kenya demo. This is the landing page of the tool, and you can see that we've already selected a pre-built scenario. However, if a user wants to create a new scenario from scratch, so the process for doing that would be to go into the Settings tab. Then the user would need to go into New Country Creation through Include New Country tab. This page is called New Country Creation page, and there are 2 steps for creating a new country. Step 1 is to define a country name. I just clicked on step 1 and the tool is asking for the country name. So I can define the country name as Kenya demo, and I would need to give a 3-digit code for it. So once satisfied, we would need to commit the country and it would appear in the table below. The next step is to populate model with Excel data. You can download a blank Excel template using step 0, and then using step 1, you can re-import that template once you've added your country data. Then there are 11 steps required to create a baseline model, starting from step 2 to step 6, where we can commit labs and hubs, health facilities, tests, demand, and modes. All of these are master tables, which are essential for building the structure of the model. The next steps are to create an admin area list, then to create referral linkages, and then to create country devices and manage number of working days, then to assign sites to devices, and finally to manage device capabilities and cost per test. Once these steps are run, the user can run step 11 and can create a baseline model. We will now go into the tool to look at the results of some baseline as well as future state scenarios. I have already opened some results for viewing. So the first tab on the left is Review Current State Network. So when we click on the summary, we will be redirected to the current state network of Kenya. This data has been cleaned and changed as per instructions of Ministry of Health, and we can now use it for demonstration purpose. So current state network helps the users understand their baseline models. Over here, we can see the different metrics, including cost, demand, devices over capacity, service distance, service time, and device utilization. Next, we go to Locations tab. In Locations tab, we can see the distribution of labs, hubs, and health facilities within the country. Next is the Capacity tab. In Capacity tab, the user would be able to understand the capacity utilization at different levels. So we can see the utilization at a national level, which is coming out to be 54% over here. But we can also see the breakup of utilization by admin 1. Also, the user can access the detailed results of the baseline model, which are at site and device level using these tables, which can easily be downloaded into an Excel format. Next, we move on to test demand. In the test demand tab, the user can understand the demand breakup by test type and also the distribution of demand as a heat map on a map. Next, moving on to referral linkages tab. This tab is an important tab where the user can identify how the referral linkages are looking across the country, and we can also filter for specific referral linkages by health facility admin, hub admin, or lab admin. Next, we will go to the transportation tab. In the transportation tab, we can see the transportation cost by admin area, average distance by admin area, as well as average service time by admin area. We can also look at the transportation distance histograms. We can look at health facility referral links over maximum allowable distance. And a key feature of the tool is to look at detailed hub and spoke transportation maps between origin and destination locations, which can be labs and hubs or labs and health facilities. This is an example of a referral map for Baringo province as the health facility admin 1 and Kericho province as the lab admin 1. And this is for HIV EID testing. And this is just dummy data. But what we're trying to show is a network with centralized testing where all of EID samples are coming to the Kericho lab from Baringo province. As an alternative to this, what we can recommend using the model is a decentralized system where we've identified 3 labs which can actually test EID samples at point of care devices. So this kind of analysis can help us compare centralized testing on PCR platforms with point of care testing for HIV EID. Now that this view has loaded, we see that because of the large volume of data, we're seeing a bit of a lag, but because we have pre-opened views, we can easily see the views we were trying to view here. So for now, I will go back to the home page and show some other details. So once the user has reviewed current state network, the user can go to change the network. Now in change the network, you can create a new scenario, make changes to a scenario, create a scenario based off a previous scenario, or make advanced changes to a scenario. Now,
moving on to hear more about the experience from the country perspective of implementing OptiDx for a DNO exercise. And it's my pleasure to introduce Paul Chunga. Paul is the laboratory advisor for the Ministry of Health in Zambia and has recently led a country exercise in Zambia using OptiDx on behalf of Ministry of Health together with partners. This was really an integrated exercise across multiple diseases and formed part of the OptiDx pilot. So it's my pleasure to ask the organizers to please show the presentation. Thank you.
My name is Paul Chunga. I'm the laboratory advisor in the Ministry of Health here in Zambia. I make this presentation on behalf of the members of the laboratory cluster. Here we report the findings from our case study where we focused on increasing access and efficiency of diagnostic networks using OptiDx. Of importance and to note is that the Ministry of Health aims to provide effective quality healthcare services to the family as possible. This ensures equity of access to health service delivery and contributes to human development as well as socio-economic development. So this is the aim of the Ministry of Health. Riding on this aim of the Ministry of Health, ourselves in the laboratory cluster, focusing on HIV and the TB testing services, we want to take HIV and TB testing services close to the family as possible, And we want to ensure that the testing services are quality assured and they are delivered adhering to the national set turnaround times. The objectives of the case study were to expand the TB program as well as to improve access to early infant diagnosis and priority HIV viral load. For expanding TB program, the focus was to increase the number of sites that are referring samples to the hub testing sites. Key to note is that as a country, we have a hub and spoke model. So currently we have about 500 sites that are in the network, but we'd want to increase that to over 2,000 sites. And with regards to EID and priority viral load, currently testing is happening on conventional platforms in a centralized manner, but we want to shift testing to point of care devices. And our key goal is to achieve on-site testing and ensure same-day delivery of results to the clients. The question we ask ourselves is that with the existing capacity, are we able to achieve this? If not, what additional capacity is required so that we can achieve these two goals. To answer these questions, we used the OptiDx. The OptiDx is the web-based open access tool that developed by FIND and the other stakeholders. With regards to the methodology that we use to do this case study, we first started by establishing baseline diagnostic network, and we focused on the 2020 testing demands. So we looked at the sample referral networks, the testing sites, the platforms that are in use, the existing costs for HIV and TB testing, as it were. Then we incorporated the future testing demands. And the key to note is that as a country, we have adopted multi-disease testing. So the future testing demands considered COVID testing, HPV testing, viral load point of care, early infant diagnosis testing. And the key platform we are looking to implement more disease testing is the GeneXpert platform. So using this data available, we then calculated the annualized cost device, the cost per test, as well as the sample transport costs. We then ask ourselves, can we expand the TB program and improve HIV access with the current capacity? We assess benefits. We assess benefits on this chart that we are looking at. So we see here that at baseline, if you compare baseline and the future scenarios, we see that on average, a sample, the distance that they have to cover is reducing tenfold for EID and priority viral load. This is a key benefit for us. And also we see that the number of tests performed on-site increases for TB and for HIV. So with these two benefits that we are seeing, we are, yes, responding in the affirmative that yes, we can expand the TB program and improve access to HIV diagnostic services. So further on, we see that with regards to the testing numbers at baseline, we see fewer numbers, but when we look into the future scenario, we see increased testing volumes, both for HIV and for TB. And we also see a corresponding increase in the utilization rate of the GeneXpert platforms. At baseline, we see a utilization rate of 16%, and when we factor in the future scenario, we see 48% utilization rate. So even if the utilization rate is slightly below 50%, but we see that there are some sites that are outliers. We see 10 sites operating at over 100% capacity, and the 84 sites operating at between 80 to 100% capacity. So key to note is that all these sites are using the 4-module GeneXpert platform. We did consider if we were to place more GeneXpert platforms, where should this go? Key to note is that we received a request from Heidi to place additional 16-module GeneXpert platforms. So we consulted OptiDx, and what we found out from the assessment that we did was that yes, we can place additional platforms, but not 10. What we found out is that it would be ideal to place 16-module GeneXpert platforms with the average tests per device of 25,000 tests. What this then does is that if we to go in this this route, the overall utilization decreases from 43% to 37%, and we see that for the fewer sites that are operating at 80%, the number of sites will reduce from 84% to 55, from 54 sites to 55 sites that will be operating between 80 to 100%. So we see that placement of the 16-module GeneXpert platforms at higher volume laboratories results in cost savings of 4%, mainly from the reduced in the pricing for the cartridges. So what are the key takeaways? The key takeaways are that yes, we can expand the TB program and improve HIV access within the current capacity. We make recommendations, 2 recommendations that we make from this case study. Number 1 is that yes, we place the 16 million expert platforms at high volume demand facilities to ensure minimum test requirements are met. And also the second recommendation we make is that we extend the shifts, the working shifts in our 4 module sites so that we can accommodate much more tests and thenceforth reduce the testing capacity from around 80% to lower numbers. So the question then is that what are our next steps? Our next steps as a country is to implement the recommendations from this case study, to implement the 2 recommendations that were made. So with this, thank you so much. And I most sincerely thank the members of the laboratory cluster, all the stakeholders, and all the implementing partners that are supporting the pathology and the laboratory services department in the Ministry of Health. Thank you so much. Thank you so much. Bye-bye.
I'd like to thank everyone, all of the speakers, Heidi, Dr. Shimemba, and Miyank, for the presentations. I know that our conference organizers have been monitoring the chat to determine if there have been any questions, but at this point, I don't see any that have been filtered my way. So I'll take this opportunity to pitch a few questions to a couple of the guest speakers. So my first question would be to Dr. Shimemba, if he could potentially share some Zambia experiences and visions and some of the use of DNO, and potentially some of the greatest lessons learned in going through this process. Dr. Shimemba? I'd like to invite the other presenters to the stage. Dr. Shimemba about to join? If not, what I can do is I can maybe pose a question to Heidi. So Heidi, based on the current pilots that have been done, there's a handful of where OptiDx has potentially been implemented to date. What would you see as the biggest hurdle and obstacles for countries to address as they move along this journey of DNO?
Thanks, Jason. Yeah, great question. I think as you would well know from experience, I think for any kind of data-driven planning exercise like DNO, one of the big challenges that we see is really the ability to compile the necessary data. And for DNO, that's coming from a number of different places. And it's not always in a standardized format, and so can be quite a challenge and a sort of intensive effort up front to make sure that all the necessary data are available and in one place. I think also with DNO, I think what we're finding is that really being able to sort of show the value of this kind of exercise and what it means. I think you've highlighted that very well in your introductory presentation, to really I think be able to show that this kind of effort and in collating the data and doing this kind of analysis is really, can bring benefits to the lab system as a whole in terms of access, but also in terms of efficiency. So making that sort of investment worthwhile.
Great, thank you for that. I see Dr. Shimemba has entered onto the screen, so maybe I should ask you a couple questions. Based on the lessons learned as part of doing the DNO in Zambia. It was a great presentation, by the way, and a lot of really salient points for our audience to kind of ponder on. But how do you see the greatest lessons learned in going through this process? What things did you think were some of the more eye-opening aspects of doing this in Zambia.
Sure. Thank you so much. Thank you. So this is Paulo Chonga, Dr. Shivemba. We didn't receive his own.
Okay.
So, and he's asked for another meeting. But to respond to the question, the key lessons that we have learned. First of all, DNO came at the right time, when as a country we were just adopting multi-disease testing, and at that particular time we didn't have a tool to use to guide us in terms of to optimize our laboratory network, as it were. So the key thing, the benefit is that our multi-disease testing implementation has been properly guided, in terms of site selection, and it's been a very, very good experience for us. We've even made a policy that going forward we shall never place any equipment without the guidance of DNO. We are even thinking of developing a document that will just guide that and speak to that, so that it is documented. So it's been a very, very great experience for us, and we are actually ready. We are already receiving invitations from other countries to learn from the Zambian experience. So it's very exciting for us, and we are indeed ready to work and assist our colleagues in the region. I think that is my submission. Thank you.
Thank you for that, Dr. Chunga, speaking on behalf of Dr. Chibemba. Maybe I should ask Miank a question, just to kind of balance the scales for all of the presenters. Miank, you did a great job on presenting the tool and how it works, but maybe you could speak to some of the system requirements and potentially some of the duration around the trainings and how long it takes for people to actually get comfortable with the tool. Based on your experience with participants that have kind of engaged and used the tool. How complex is it? Is it easy to use? How long does it take to become proficient in using the tool?
Thanks for that, Jason. That's a great question. So from our experience, based on the pilots we've done, the first stage takes the most time, which is data collection. So that can be done independently of the tool. It is based on data templates. Once that stage is complete, so that can take anywhere from 3 to 4 months based on our experience. The next stage is to build the first model, which is generally called the baseline model, and which would represent the current state of the country operations. So that part is done on OptiDx, and for that we provide training to the different participants from ministries and from partners. And from our experience, I think once a data analyst is comfortable building the baseline model, then the next stage is building scenarios and maybe creating subsequent models and detailed analysis. That should not take long, but I think the key stage would be to learn how to build the baseline model. And that might take another, from what we've seen, roughly 2 to 3 months to understand the network completely. So that is my submission. And I'll let Heidi add to that.
Thanks, Mike. I mean, I think you covered it very well. I think what we've been finding, I think, with any kind of DNO and OptiDx no different, that really, and I think this is why the work in Zambia was really very successful. That it's really a team sport. So there's a lot of different stakeholders and team members that are really needed to make a successful DNO exercise. So the one would be the sort of analysts who are really interacting directly with the tool. And I think that's more what sort of Mayank's speaking about in terms of those different data sets. But I think there's obviously the much broader group of people who, the decision makers, the sort of more senior leadership, and then a range of different partners that, understand, sample referral, some of the more operational things, this kind of thing. So we're really sort of seeing this at two levels, the sort of strategic decision makers, really to understand the concepts around DNO, the sorts of questions it can help you answer and how to use those outputs, as you explained. and then the analysts. And I think it's sort of early. So we've been piloting this in 4 countries. We've had sort of different experiences, but I think what we're seeing is a sort of initial sort of intensive training, like Mayank's mentioning, but then some kind of coaching as countries start to build their own models and then add in sort of more complex scenarios depending on the sort of questions they're trying to address. So I think it's an ongoing process. I think the tool is as simple as we've tried to make it as simple as possible to answer the sort of questions that countries are hoping to answer. And I think as Powell mentioned in his presentation, that those can be quite complex, especially when you're thinking about multiple different diseases and tests within a network. So I think that does take a bit of time to really build that advanced proficiency. And so, as FIND and as USAID and other partners, we're there to sort of provide that kind of ongoing support to make sure that can happen.
Yeah, thank you for that. I did see in the chat that we did get one question, and I want to be cognizant that Sergio does have to do closing remarks, so maybe I can hand this. You don't want to do closing remarks?
No. I'm more interested in people engaging with
questions.
Yeah,
exactly. Yeah.
I see some of my colleagues in South Africa very quiet, and Lee Schroeder here. So happy for you to encourage some discussion here, Jason. Go ahead.
So the question in the chat, maybe I can hand this to Mayank, because this was basically in regards to the Kenya pilot where you showed some of the data, but I guess it's in relation to centralized testing. Was it considered as part of the analysis a more centralized approach instead of a decentralized? I know that you were showing dummy data, so maybe there was kind of some confusion in relation to that, but I do know that there has been some pilot work in Kenya, so maybe either Heidi or maybe
maybe let me take that question. So I think we've presented previously on the work in Kenya with colleagues from the NTP leading that. So that was pre-OptiDx. That was using a commercial software, but very, very much related to OptiDx. So built on the same sort of foundational platform. And so what Mayank was showing, and that focused primarily on GeneXpert, but also looked at the sort of culture and susceptibility testing labs. So what Mayank was showing today was some dummy data, and the NTP were kind enough to allow us to use some of the sort of site information, but to change the rest of the data. So it is just a dummy data set that we were presenting today.
I figured as much. So with that, Sergio, the time is upon us. I'm going to hand it over to you to do some closing remarks, but I'd just like to thank the organizers of this session for allowing me to participate, and hopefully folks that attended learn some things about the new tool and obviously have a better appreciation for DNO. So thank you very much. Over to you, Sergio.
Great. I'll try to keep it quick and brief. So first of all, thank you, Jason, Heidi, Mayak, and Powell for your presentations today. Clearly, to me, is DNO, Diagnostic Network Optimization, is coming of age. It's hard to believe that in today's data-driven world, it makes no sense that we can have a really good understanding of what people's shopping habits could be, yet health-seeking behavior is much harder to capture. Yet in many low and middle-income countries where access to care is often very limited, we're seeing diagnostic equipment still sitting idle. Or oversubscribed, so in some areas not used, and in others really overburdened. And my colleagues here on the meeting today from South Africa know this very well. And it's hard to understand why from the onset we don't look at demand and of diagnostic and health services and use these kind of tools to optimize both our clinical services and how we provide diagnostics here. Seeing Lee Schroeder here also reminds me of how it's not only about diagnostics, but also understanding what the essential medical treatment tools or drugs in these facilities together with diagnostics need to match and address a better use of both. DNO is a critical means to improve access to diagnostics and diagnosis by increasing both network efficiencies, as we heard today, optimizing resources and enabling a better both management and visualization of these diagnostic needs. We really want to commend ASLM also for welcoming the focus on DNO at this conference. We've had 3 sessions that have been coordinated by the IDC, the Integrated Diagnostic Consortium. ASLM remains a critical partner to make this essential and help us move this forward. So you can see here from this slide I'm sharing that more information is available on the FIND website, and you can find it there. This is also an opportunity to remind everyone that OptiDx is an open access tool. It's web-based, so it should be fairly easy to use. Jason and Heidi, you are available to engage on this if there's any questions after the conference. And as you may have heard on Monday, we announced new funding from the Bill Melinda Gates Foundation that will support the expansion of OptiDx use and local capacity building. So in actual 15 low and middle income countries. So it's a big project for the next 3 years, and we are looking forward to seeing the outcomes of that. So thank you very much to all of you, and enjoy the rest of the conference.